Next, we have Dr. Faizan Saleem from McMaster University. Dr. Faizan is a molecular microbiologist with a diagnostics mindset, linking microbial community profiling and targeted detection to real-world outcomes. Skilled in designing and executing workflows for environmental monitoring and clinical screening, with strong attention to microbiome-informed diagnostics for improved public health strategies. Growing up as the eldest child in a joint family with many children, Faizan still finds his only form of entertainment is Japanese anime and manga. So please welcome this anime fan, Dr. Faizan Saleem.
Hello, everyone. Thank you very much for coming here and attending our talks, listening to us. It's tough, I know. So before I actually begin with what I do or what my research is about, you all would know that a lot of taxpayers' money go into funding our research, right? Millions and millions of dollars. So with great money comes great responsibility, right? So that has been my goal, my motto, to use that money, the taxpayers' money, for their own benefit. What am I providing to the public through my research, right? So today's talk is not actually about me discussing my results. Oh, look, I have this graph or no. No. Today's talk is about how through my research, I'm actually helping a common man or general public who is actually funding for us. So before further ado, let's begin with a focus on one thing, and that is water. And how many of you actually know what bacteria are? Just raise your hand. Perfect. That makes my life easier, right? You know what is the most common thing between a graduate student and bacteria? They take too long to grow. And by the time they grow up, they may not be as useful. So actually, growing bacteria takes about 24 hours. And more than 90% of the diagnostics being done in clinics, environmental side, or anything that you can think of, right? It's being done through growing bacteria. That means sample collected today would not provide you the answer till tomorrow, right? You may think, oh, just 24 hours. Think about it. You go to the beach, right? You're swimming there, you're enjoying your time. You don't know the water quality yet because the samples were collected today, results would be tomorrow. But by tomorrow, you would know yourself because you would be sitting in your toilet whole day with diarrhea. Probably, right? So that's what I'm trying to fix. That's one problem. I want to make the microbial diagnostics faster. So another problem is you're testing for one bacteria, but you must have heard that there are millions and millions of those, right? What about the others? Are they not there? Are they not important? Are they not pathogens? Let me tell you, there are many of them. But through the traditional diagnostics of growing bacteria, we don't really get additional information, including from viruses, other bacterial pathogens, what are the contamination sources, protists, and so on. That's the second problem I'm trying to fix. Get more information, provide more information, making tests, diagnostics tests robust, comprehensive, and faster. How I'm doing it? The simple answer is DNA, right? You all know DNA. And specifically, I'm talking about the DNA that is present in the water, which is and the DNA is coming from all the bacteria, viruses, all the organisms that are interacting with that environment, right? So the first things first, how to make the diagnostics, water diagnostics or clinical diagnostics faster. We do it by targeting the DNA region of the targeted organism instead of growing that bacteria or growing that organism. So instead of getting the results in 24 hours, we can use the DNA amplification technology by get the same results in about 4 hours. It's much faster, right? Makes your life easier. And if you want to read more about it, of course, you can read the manuscripts that I have published. Again, I'm not going to discuss any results here. I'm just trying to make your life easier. Second, more target specific, right? Making things error-free, foolproof. When you're testing for something that is a pathogen, you don't want any errors in there, right? So another part of our research or my research is basically identifying through our collaborators certain DNA segments, very specific DNA segments that are present only in the targeted bacteria, but in no other organism, right? That part of the DNA We use that to develop amplification or DNA targeting strategies that can give you error-free, foolproof diagnostics, and you know that the results that we are getting are actually 100% true. If you want to read more, of course, you can look into the manuscript. The third one, as I said, when we grow bacteria, we're going one at a time. We are not getting the additional information out of it. What about the harmful algal blooms? What about the protists, viruses, and stuff? You must have heard about DNA sequencing, right? We can use the DNA sequencing to develop strategies, and that's what I do as well, to not just target one bacteria at a time, but the entire population, what are there and what they can do. So you get the entire profile of it. You get the entire spectrum instead of just targeting one thing. And again, if you want to read more details, it's the manuscript. Last but not the least, identifying the contamination sources or fecal contamination sources in the context of water. You can keep on testing water forever, but that doesn't get rid of the root causes, right? To get rid of the root causes or for the long-term preservation strategies, we want to identify where that contamination is coming from. So again, using the DNA sequencing technology, we can identify the biological fecal contaminants and develop the preservation mitigation strategies to stop the influx of that contamination into the waters to fix the root cause. And you can read further about it again. And thank you very much for listening to me.